All right, welcome to Unit 4. This unit involves quadratic expressions. Now, before we get into that, we need to review a little bit about algebraic expressions and the distributive property. When we see something like 4 bracket x plus 2, if we were to expand that, that would tell us that we would multiply 4 times x, which should give us 4x, plus 4 times 2, which would give us 8. A negative by itself, without any numeral, is the same as negative 1. So negative bracket x plus 1 is the same as negative 1 x plus 1. And that would expand to negative x minus 1. Here are a number of examples that we'll work through. 2 bracket x plus 1 expands to 2x plus 2. 2x minus 7, bracket 6, would expand to 12x minus 42. In this next example, the 2x is not next to the brackets, so we're not going to multiply the 2x times anything inside the brackets. We'll just put the 2x by itself, and then we'll multiply negative 1 times x, and then negative 1 times negative 1. Collect like terms. 2x minus 1x is x plus 1. Once again, in this example, the 3y is by itself. It's not next to any brackets at all, so we'll just write it in by itself. And then we'll start multiplying the 6 times the values inside the bracket. 6 times 2y gives us positive 12y. 6 times positive 1 gives us 6. Collect the like terms. 3y plus 12y gives us 15y plus 6. In the next example, the 4x is by itself. We would just write it as such. And then plus 1 times 3x plus 1 times negative 1. Collect the like terms. 7x minus 1. In the last example here, we'll take the negative 5 and multiply it by 4x to give us negative 20x. And then the negative 5 times negative 10 to give us positive 50. In this exercise, we're asked to collect like terms having the same variable raised to the same exponent. Simplify equations by collecting like terms. A simplified expression will have no like terms. So we've got this example A, 2b plus 7a plus 8b minus a plus 3b squared. We have a single term that has b raised to the exponent 2, just a single term, so we'll just write this by itself. And then we have two terms with a in it, positive 7a, negative a. They simplify together to become positive 6a. And then we have 2b plus 8b, which add together to be 10b. In example B, we have a negative x squared and a positive 3x squared, which results in a 2x squared. Then we have a positive 2x plus 3x, which results in a positive 5x. and then a -4 and a 3, which results in a -1. When we're finished, we have no like terms. We do not have more than one like terms in our expression. In this example, y plus y plus y can be expressed as 3y. Y times y times y can be expressed as y to the exponent 3. Working backwards, we can say that a to the exponent 3 is the same as a times a times a. 2 to the exponent 3 can be represented as 2 times 2 times 2. Example C has the expression 2y in brackets to the exponent 3. This is the same as 2y times 2y times 2y, which could be written as 4y squared times 2y, and ultimately 8y cubed, or 8y to the exponent 3. In our example D, we have 3x by itself, and then we have negative 3x in brackets to the exponent 2. That means that the negative 3x can be to the exponent 2 can be rewritten as negative 3x times negative 3x, eventually resulting in 9x squared plus 2x minus 1. It's just a rule of some of our exponent rules. A to the m plus a to the n equals a to the m plus n. In this exercise, we're given an expression and then provided a value for the variable. So 2x plus 3, where x equals 3, can be rewritten as 2 bracket 3 plus 3, which results in the expression 6 plus 3, and that should actually be 9. So that's a mistake that I have there. So this particular expression, the answer should be 9. Apologies. Next example, 2x plus 3, where x equals -4. So 2 times -4, oops, wrong expression, 4x squared. Now, the x squared, the exponent applies only to the x, not to the 4. This is an important thing to realize in expressions like this. When you see an exponent like this, it applies only to the variable that it's next to. So if x has a value of 2, we first do the exponent, 2 to the exponent 2, which is 4, and then we multiply that by 4 to get 16. Back up to 2x plus 3, where x equals -4. Substitute the -4 for x. 2 times -4 is -8, plus 3 will give us -5. Now in this example, unlike the other 4x squared, the brackets are around the 4x, and everything that's inside the brackets, the 4x, is raised to the exponent 2. So first we have to multiply 4 times 2, which will give us 8, and then raise that to the exponent 2. So 4 times 2 is 8. 8 to the exponent 2 is 64. compare that to this expression over here. Okay. Without the brackets, the answer is 16. With the brackets, it becomes a completely different answer. Now, being able to factor numbers is going to be a very important part of this unit. We'll have to factor quadratic expressions. To be able to do that, we'll have to get quite comfortable with factoring numbers. So here we've asked for the factor of 20, which means what are all the numbers that can be multiplied together to give us a value of 20? Well, 1 times 20 will give us that. Negative 1 times negative 20 will give us a value of 20. 2 times 10, negative 2 times negative 10, 4 times 5, and negative 4 times negative 5 will all give us 20. So these are all factors of 20. In this example, we're asked for factors of 16. The factors of 16 are 1 and 16, negative 1 and negative 16, 2 and 8, negative 2 and negative 8, 4 and 4, negative 4 and negative 4. All these pairs of factors will multiply together to give us a value of 16. Here we're asked to come up with the factors of negative 27, and these are 1 and negative 27, negative 1 and 27, 3 and negative 9, and negative 3 and 9. All of these pairs of numbers will multiply together to give us negative 27. Here, there's a little mistake here. I believe this is supposed to be the factors of negative 12. 1 times negative 12, negative 1 times 12, 2 times negative 6, negative 2 times 6, 3 times negative 4, and negative 3 times 4 will all give you a value of negative 12, which this should be reading right here. In this example, we're asked to find two integers that meet the requirements. Now, the requirements in each of these cases is to find a pair of numbers. Numbers that multiply to, in this case, 24, and add together to be 11. These are the same pairs of numbers. There is a pair of two numbers with multiplied together will give you 24, and if added together will give you 11. This is really important to be able to do in order to factor our equations, a subject that we'll be getting to later in this unit. So, what are the factors of 24? What are the two numbers that will multiply together to be 24? We've written them all here. Here's the pairs of numbers. Now we have to choose from these pair of numbers and see from these pairs which of these two will add up to 11. Well, in this case, 3 and 8. It matches both of the criteria. They multiply together to be 24. 3 times 8 is 24. And they add together to be 11. 3 plus 8 is 11. In this example, we're looking for a pair of numbers that will multiply together to be negative 36 and add together to be negative 9. So we start by listing all our multiples of negative 36. And these are all the pairs of numbers that will multiply together to be negative 36. Now we're looking for a pair that will add together to be -9. And that pair happens to be 3 and -12. 3 times -12 gives us -36. 3 plus -12 gives us -9. In the last example, we're looking for a pair of numbers that will multiply together to be -12 and add together to be 4. We start by listing all our factors. All of these pair of numbers will multiply together to be -4, and then we choose from this list which of these pairs will add together to be 4. Well, in this case, -2 and 6 match that criteria. -2 times 6 is -12. -2 plus 6 gives us 4. So it matches both of those criteria.